Hey guys, welcome back. So got another video for you here today. This is going to be the practice midterm part 1 solution. So the first 10 questions, which is what you guys did yesterday. So sorry it's going to take me a day of delay just to gather the data and put the stuff together, put the video out. I know you guys are used to having that immediate feedback because that is what's best, but thanks for being patient, and make sure that you're looking through your PDF and do submit and turn in the PDFs. I'm going to take homework grades on these just so you guys kind of do it. But anyway, do make sure you fill in the PDF so that you can see your work and follow back through while you're watching along with the video to see what you did wrong. So you guys submitted to Mastery Connect, you know what your raw score was, so now let's figure out what problems you missed and why you missed them and what some of the most common mistakes were. So 57% of you guys still haven't taken this, so if that's you, won't go any further. Please take the actual practice test first, okay? Try them out, see if you can figure out how to do the problems, because those are the same types of problems you're going to see on the midterm. If you just skip and watch straight to the solutions, that's pretty lame, first of all, but two, it defeats the whole purpose, right? So really you want to figure out what you knew at the time, what stuff you still need to review, and then make sure that you're ready for the midterm when you come back. By the way, not trying to be cruel or anything. I understand it's a little midterm. I'm giving you guys a test when you come back. So we are going to call it something else. In fact, instead of calling it a midterm, I'm going to change the name to the Super Happy-Go-Lucky VeggieTales Test. So that is what's going to be on the name of the title of the midterm. Instead of calling it a midterm, it's the Super Happy-Go-Lucky VeggieTales Test, because that just sounded happier and less intimidating than the midterm. But anyway, it's still a midterm. Yeah, so let's get into this without any further ado. How about now? All right, cool. So on number 1, 30% of you guys missed this one. This was the most missed problem from the first time we took the test, right? Unit 1 test. But it seems like some of you guys are still struggling with this. So whenever I go over my angle pairs, we have alternate interior angles, alternate exterior. I really should add to that a linear pair. So a linear pair is a pair of angles that are supplementary and adjacent. So together these two angles add up to a straight line, okay? So I know they don't give you the diagram. I need you to know what the vocab is, right? So I'm going to throw something at you: complementary, supplementary, linear pair, vertical, corresponding. I'm going to throw something at you, and I need you to make sure you know how to solve the equation even without being given a diagram. So the real question is, do you know what a linear pair is? Do you know that vocabulary word? That's kind of what I'm testing on this one. All right, so angles 1 and 2 are linear pair, which we know means they're supplementary. So what we want to do is to set this up. We have angle 1 here, and we have angle 2 here. So visually, that's kind of what it looks like. Together, we know those two angles have to add up to a straight line, which is 180 degrees. So we're going to set up our equation with the angle addition postulate, and we're going to say that the 6x minus 12 plus the 4x plus 42 is going to add up to 180. Our next step is to combine our like terms. We're going to combine the terms that are on the same side of the equal sign. So I'm going to add the constants together and the variables, the x to the first powers together. So it's going to be 10x plus 30 is equal to 180. Then we need to get the x by itself. We got to get rid of the multiplication and the subtraction, but we want to do the subtraction first. So we're going to subtract 30 from both sides, leaving us with 10x is equal to 150. And then the last step is going to be divide by 10, and it leaves it with x is equal to 15. Okay, so the most common mistake was right there. So you saw angle 1 is equal to 15. That's not what we're doing. X is equal to 15. Angle 1 is not equal to 15. Did you see what you did wrong? So quite a few of you guys missed these problems, and if you missed it on number 1, you probably missed it on number 2 and number 3 as well. So there's no reason for you to miss, because you set up everything, you got the value of x correctly, you just simply didn't read the question carefully. So they want you to find the measure of each angle. So first you find the value of x, then to solve the next part, we plug it back in right here. So x is 15, so we have 6 times 15. That's a terrible 15, you get the idea, minus 12, and that's going to give us the actual answers, which I guess I'll pull out a calculator, even though I'm super lazy. So 6 times 15, and then we're going to add or subtract 12 from that, which is 78. So the measurement of angle 1 is 78, and then we know angle 2 has to be 102. You can plug it in here as well, but remember these two add up to 180, so if we do 180 minus 78, it's going to be 102. Okay, so the correct answer should be C as in Charlie. The other thing that you might have done wrong is you set them equal to each other, which would be how we would solve it if they were vertical angles or congruent angles, alternate interior, alternate exterior, anything like that. Then they would have been congruent, so you set them equal to each other, and that's where you got this 150 when you plugged them back in. Okay, so do be careful. That apparently tripped up some of you guys as well. So a linear pair adds up to 180, and once you get the value of x, look very carefully. It's not x is equal to something. That's not your answer. Okay, so you got to plug it back in. All right, moving on. Number 2, angles 1 and 2 are vertical angles. Do you remember what vertical angles are? So again, you won't have the diagram here. So I put the diagram, but vertical angles are opposite angles formed by an intersection. And so for instance, they could look like this, right? And what's special about vertical angles is they are congruent to each other. It's one of our angle pairs. It's kind of the first one that we really learned about, except for a linear pair. So what's special about them? Well, they're congruent, so they are equal. We don't know what they add up to. So the most common mistake was people added them up like they were supplementary, like linear pair, like on the last problem. But that's not true for vertical angles. They're going to be congruent. In fact, more people miss this problem than the last problem, which is surprising, even though we just did a unit over vertical angles. So you should know that one. But anyway, so we're going to subtract 4x from both sides. I guess when you don't have the diagram, it throws you off. But again, the whole point is I was trying to see if you remember what vertical angles are without diagram, without any help. So we have 4x minus 12 is equal to 36. Then we add 12 to both sides, and we get 4x is equal to 48. Divide by 4, we get x is equal to 12. So x is 12, so the measurement of angle 1 is 12. Is that it? Nope. Okay, probably the same people missed that one, right? So what we have to do is plug it back in. So we have 12 here. We want to plug it in up here. So 8 times 12, handy dandy calculator. All right, so 8 times 12, and then enter minus 12 is going to give us 84. So measurement of angle 1 is equal to, so I can write it here if I want. So measurement of angle 1 is equal to 84. And if these were equal to each other, then if I plugged it in here, the measurement of angle 2 also is going to be equal to 84. And sure enough, it is. So that is our answer, which is C as in Charlie. Ouch, Charlie, that really, quarter altness, half altness, 8 altness. All that good stuff. I love accents. They're so much fun. Why be normal when you can be crazy? That's going to be a thumbnail. All right, so anyway, we have angles 1 and angles 2. That was the most common mistake. You would have gotten these answers if you set them up as a linear pair and supplementary to each other. And so that was actually the most common mistake that you guys did. So again, vertical angles opposite of each other on the intersection, and they're congruent because they're the supplement of the same value. So for instance, if this was 84 degrees, then we know the supplement of that's going to be 96. And again, this is obviously not to scale. And then the supplement of 96 is going to be right back at 84. Remember, that's how we prove that vertical angles are congruent to each other. Okay, number 3, we have angle AOB. So AOB, that's this angle here. I'm going to go ahead and label that. And then measurement of angle BOC. So BOC is right here, BOC. Then what's the measurement of BOC? So, well, BOC is 3x plus 22. No, we got to find the actual measurement, so we got to solve for x first, then plug it back in. All right, so on this one, looking at the diagram, they don't tell us AB is not a midpoint, a bisector. Okay, so we don't know that OB bisects this angle. We don't know if they cut each other in half. So the most common mistake is if you just set them equal to each other. That's an assumption we can't make unless they tell us that ray OB bisects angle AOC. But what do you see? Is there anything that you see here, anything that is colored purple that you notice? Hint, hint. Yes, that is a right angle. So we know these two angles are complementary, meaning they add up to 90 degrees. So I might even ask a question, and just like I did on the other ones, and say angles 1 and 2 are complementary, which you would need to know means that they add up to 90. So how are we going to set up this equation? Well, we add our expressions together, and we set it equal to 90 degrees. Then we combine our like terms, so that's going to be 8x plus 34 is equal to 90. Subtract 34, then divide by 8, and we're left with x is equal to 7. So is that what the measurement of angle BOC is? And again, that was one of the most common mistakes. No, the measurement of BOC is not 7. That's what x is equal to. So to find BOC, we have to plug it back in. So here's BOC. I'm going to plug in 7. So 3 times 7 is 21 plus 22 is going to be equal to 43. And so that's going to be our answer, which is D as in delta. All right, cool. So answers are kind of all over the place on that one. I think if you set them equal to each other, you would have gotten 5. And if you plug those values in, you would have got 37. So that's what those two wrong answers, distractors, were. And then 7 was the most common mistake that we saw, which is if you forgot to plug it back in. So again, don't forget to plug it back in. Make sure you read the question, what are they asking for, and make sure you read the answers as well, because I could have just said 5, 7, and 37, and 43, but I actually told you, again, measurement of angle BOC is equal to that value. Okay, cool. Number 4, EF FG, and EG. So this is the angle addition postulate, which again we reviewed yesterday, which I thought was pretty helpful. You're welcome. So EF, I'm going to label the diagram, is here. FG is here, and then EG is the whole thing right up there. So I want to add these together. So the green plus the blue is going to add up to the whole thing, which is 50. So that's going to be my expression or my equation when I set it equal. So add the two small parts together. It's going to add up to the whole thing. And combine your like terms, so 5x plus 20, we're going to subtract 20, then we're going to divide by 5, which leaves us with x is equal to 6. And that actually is the answer. See, it says x is equal to 6, not EF is 6 or FG is 6. And again, this should say, I guess I should change that, it should say find the value of x. Our answer is x is equal to 6. Most of you guys got this right. The 14, I think, is if you set these equal to each other. Again, we don't know that f is the midpoint, so we can't assume that it's the midpoint. We can't just set them equal to each other. The same assumption that you guys made with these two, with OB being a bisector. Excuse me, we can't assume that. We can't just set them equal to each other unless they tell us that it's a bisector or a midpoint. All right, now speaking of the devil, here we have if T is the midpoint of SU, so T is the midpoint, what does that mean? Well, that means that these two segments are going to be congruent because T cuts SU into two congruent segments, which means their expressions are going to be equal. So on this one, we do set them equal. We don't know what they add up to, but we do know that they're equal to each other. So set them equal, subtract 3x from both sides. If we subtracted the 7x, we'd have negative 4x. We don't want to deal with negatives if we don't have to because it's just more likely that you're going to make a mistake. So we always subtract a smaller amount in case you're wondering. So I'm going to move the x's to one side, which will be 4x minus 12 is equal to 24. Then I'm going to add 12 to both sides, which leaves me with 4x is equal to 36. Then divide both sides by 4, which leaves me with x is equal to 9. So our answer is C as in Charlie. All right, number 6, find the distance between the points here and here to the nearest tenth. So we're using the distance formula. I prefer to graph these out and use the Pythagorean theorem because that's how I roll, because geometry is better than algebra. Yeah, take that. But anyway, we can label the points. This will be our first point. This will be our second point. So here we have our x sub 1 and our y sub 1. And here we have our x sub 2 and our y sub 2. So x2 minus x1 is 9 minus 5. And then 3 minus a negative 2. Be careful because it is minus a negative 2, and when we subtract a negative, remember that's going to become plus a positive, so you want to go ahead and change those. So 9 minus 5 is 4, and then 3 plus 2 is going to be 5. So 4 squared plus 5 squared, that's going to be 16 and 25, which adds up to 41. And then lastly, we take the square root of that, which is going to be 6.4. So the most common mistake I can already tell you right off the bat is when you get to the 41, you're like, oh, that's one of my answer choices, so I must be done. But don't forget, you do take the square root of it. It's in the formula of the whole thing, so don't forget that. So the square root of 41 is the 6.4. So that got 14% of you guys. And I can almost guarantee you I am going to put a distractor just like that on the test because I want to, make sure that you finish the problem out and don't just see one of the intermediate steps like you see here, like how I tricked you guys on the whole x is equal to whatever whenever we were asking for an intermediate thing and you got to plug it back in. Yeah, so that's how tests are typically written, and so you need to be aware of that. And what's sad is you guys know how to do these problems, you just are rushing through it or you're not paying close attention or whatever. So some of you guys say like I'm a bad test taker. Well, if I'm doing the same things to try to trick you on the test and you fall for it every time, yeah, that's on you, right? So, and we're doing the practice test together so that you guys can get the exposure to my tricky, devious ways and how people in general write tests so that you can make sure you don't make those mistakes. Because I would make simple mistakes on my test too, and it's like, wow, I knew how to do everything. I just always make some mistakes. And don't be too hard on yourself. We're human. We're gonna make mistakes. Okay? We just want to learn from those mistakes. All right, number 7. Find the coordinates of the midpoint of the segment. Everyone got this one right, except 8%. So we were just taking the average of the x's and the average of the y's. So negative 2 and 8 is going to be 6. So that's going to look like that. And then 11 plus negative 7 is going to be 4. So we have half of 6 and 4 is going to be 3 and 2. So the midpoint is 3, 2. I'm not sure what the mistakes were here. Is probably the negative that you didn't do right, or you switched the signs or something like that. I'm not sure. So just be careful. Most of you guys got that right though. But the others could be guessing. I'm not sure. All right, so what's the area of the following figure? So we need to break the figure down by deconstruction. This is very similar to the problem that we had on the test the first time. So it's a good problem. I like it. It's fairly simple, but it makes you do some stuff. So first thing, we need to find the missing side links here. So to find the green link, that's going to be the width 14 minus the 8, which is going to be 6. okay? And then for the red length here, that's going to be the height of 9 minus this little height of 5, which is going to be 4. So now that we have that, we can find the perimeter and the area. So to find the area, I went ahead and extended this line, just drew it down here, and then I'm going to find the area of this rectangle and then the area of this rectangle, and add them together. So 5 times 6, so base times height. We're not actually dealing with the 14, so that's a common mistake. The most common mistake I think on this one was C as in Charlie. And that's because you did 14 times 9. That would be true if this was actually filled all the way in. So let me see if I can do that better. But like if this was a rectangle where this whole thing was filled in, then that would be correct. It would just be base times height, right? So it would be 9 times 14. But the problem is this whole area right here is not filled in. It's a gap, right? So you got to subtract that area. So anyway, that was the most common mistake that we saw in this one. Anyway, so 5 times 6 is 30, and then 8, because 8's only this top part, not the whole 14. We just want the top part of this little rectangle here. So 8 times 9 is going to be 72. Then add those two smaller areas together, because we found area by decomposition. So we broke them down into smaller parts, found the areas of smaller parts, and add them back together. So 30 plus 72 is going to be 102. So the correct answer is A. And then the most common mistake we had was the 162 or the 126. 162. You see, that's dyslexia, pretty active. Anyway, so 9 and 14. That would be how you get the 126. So anyway, don't make that mistake. That's why we do it now. All right, so next thing we want to do is find the perimeter. So I've already broken it down and give you the same diagram so you don't have to do any extra work. You're welcome. And just broke it down into problems. So now find the perimeter, just find the area of the outside going all the way around. So add them all up, 5 plus 6 plus 4 plus 8 plus 9 plus 14, put it in the calculator, double check your work in just in case you got something wrong. It's going to be 46. So that's going to be C as in Charlie. Not sure what the common mistake here. I think the 42, that could have happened if you skipped that, okay? Because you didn't actually have to have the 4 to find the area. You just needed the 6, right? So if you just skipped over that part there, then that could have been an answer choice as well. So that might have got some of you guys. All right, number 10. This is very similar to the last problem we had on the very last question we had on the Unit 1 test. So let's go through it again. Anyway, so we want to find the perimeter of the triangle. We can find the base here is 14 because we're going from -4 to +10. So that has a length of 14 on a number line. So we got the 14, but to find the other links here, we can't just count, okay? We actually have to use the Pythagorean theorem and set it up. So if I counted 1 1/2, 2 3/4, 3, 4, 5, I know my brain hurts. That was really painful. So the reason we can't just count is because this is not like the linear Diophantine equation. So fun. Or the integer solutions, okay? So it's not like it's on an X or Y axis here. So we can't just count going straight horizontal, straight vertical, okay? So when we have diagonals here, we're dealing with a distance from the Pythagorean theorem. So break it down. Drop in altitude here. So we have 7 going from 10 to 3. So that is 7. And then we're going from 6 to 10, which is 4. So we have 7 and 4. So that's going to be 7 squared plus 4 squared, right? And remember what's in between the legs of the right triangle. All right. So we have 7 squared is 49 plus 16 is going to be 65. Then the last step we're going to do is take the square root of both sides. So square root of 65 is going to give us our decimal answer of 8.1. Same thing on the other side. We got 7 and 10. Okay, you could count that out if you want, but we're going from 6 to -4, which is 10. So 7 squared and that's going to be 100, and 49, which is 149. Square root of 149, same thing, is going to be 12.2. So now, last step, we want to find the perimeter. We're going to find the area, or sorry, not the area, but the perimeter going all the way around. So 12.2 plus 8.1 plus the 14, which is going to be this whole mess down here. Add them all together, which gives us our final answer, which is D as in delta. All right, cool. And then one of these answers is probably going to be the area, which would be 14 times 7 divided by 2. So 7 times 7 is 49. That would probably be one of the distractors. Don't fall for that one because we are finding the perimeter, not the area. But now you know how to do it. So right under 20 minutes, and I got to cut some of that out because there was some other things going on there. But anyway, I will see you guys later. If you have any questions, again, I'm always live on Google Meets from 11 to 12. We've been having a lot of fun, by the way, on Google Meet. So if you want to join, it's a riot. There's usually like 8 to 10 kiddos that do that. But unfortunately, this might be like the last week that we can do Google Meet. So come on, join us, meet some new people, some of your potential classmates, and most of them are freshmen from CAPS, by the way. But anyway, join us. It's a lot of fun, 11 o'clock to 12 o'clock, and the link for that is in either down by the syllabus at the very end of the class link, or I might just post something again tomorrow. But anyway, if you have any questions, you can ask those questions during our social time for the tutoring, or also if you really need help, we can do some private tutoring sessions while I still have time to do that before we go back in person, and I won't have as much time. So I'm surprised you guys are still listening to me. What are you doing here? Get out of here. Go do your work. I'm just kidding. See you guys. Farewell.